Hi, my name is Nurul Syuhada binti Mohamad from Group 6. Now, let me introduce you to my group members.
Hi everyone, my name is Nurul Asyiqin binti Harishadi.
And hi everyone, I am Wan Nur Anatasha.
What are you thinking about, Shu?
Oh, I'm thinking about on how to solve a question that involving an application of differentiation. I don't know what to find first. Do you have any idea, Anatasha and Asyiqin?
Oh, it's easy. I actually have a few tips for you.
Yes, it's easy issue. I also have a few tips that always help me to answer this kind of question. You want us to share it with you?
Yes, of course. I'm so grateful for that.
Okay, first and foremost, find the important message or information given from the question. Mostly, the question will state what kind of shape of object. Therefore, for more understanding, you have to illustrate the picture.
Not just that, Shu. After you can understand the question and the pictures involved, they will be given two variables for you, usually x and y. But if the question don't give it, just create it. Therefore, firstly, you have to find the value of one of the variable given. To find it, use the formula first derivative equal to 0. One more thing, to determine whether the critical point is at maximum or minimum, find the second derivative of the equation. If you get a positive answer, then it is at a minimum point, and if you get a negative, it is at a maximum point.
Wow, that will be a useful tips for me. Thank you in advance. But I'm still think I need to do some exercising for more understanding.
Okay, then let's continue to some exercise.
Let's go!
Okay, now let's move on to the question that we are asked to do. We actually given 3 questions in total, so my role here is to presenting and show the solution for the question number 1 for MAT183 assessment. So here is the question. A rectangular plot of land is to be fenced using 2 kinds of fencing. 2 opposite sides will use heavy-duty fencing at the cost of 6 ringgit per meter, while the remaining 2 sides will use standard fencing at the cost 4 ringgit per meter. If the total cost of fencing a rectangular plot is 1,200, find the dimension of the rectangular plot of greatest area. As you guys notice, I actually highlight the key point here using the red bold. So here are the key points. First key point is a rectangular plot. Like I said earlier, to understand the question better, we can illustrate the picture. So that's why I'm gonna illustrate the picture of rectangular shape so that we can see it more easily. Also, for the second key point is 6 ringgit per meter for 2 opposite sides. So here I assume that the length is the 6 ringgit per meter, and to make it easy, I put it as an X, while the number 3 key point is 4 ringgit per meter for another 2 opposite sides, and I put it as a width as Y. And the total cost of fencing is 1,200. Okay, so here are the solutions. First and foremost, we actually have to find what kind of equation, what kind of formula we are going to put so that we can find the solution. So first formula that I'm going to use is parameter formula. Since it's already given the total of cost, which is 1,200, we can actually use parameter formula. So here is the parameter formula, which is 6 multiplied by 2x plus 4 multiplied by 2y equal to 1,200. And we can just simplify it, and we got 12x plus 8y equal to 1,200. To simplify it, we actually have to divide the both sides by the greatest common factor, which is 2 here, and we got 600 equal to 6x plus 4y. Then we can solve for y. Either we can solve for y or x first, but I here to solve y first. So we have to let y alone. So take the parameter formula equation 600 equal to 6x plus 4y, and let y alone, which is we get y equal to 600 minus 6x divided by 4, and we got y equal to 150 minus 3 per 2x. Since we have to maximize the area of the rectangular, So we can set up the equation of area, which is area equal to length multiplied by width, which is x multiplied by y. So we already have the value of y, which is 150 minus 3 per 2x, and we just substitute it into the formula, and we got this, and we just simplify it, and we got a equal to 150x minus 3 per 2x squared. Then we can take the derivative of a, and we got a prime equal to 150 minus 3x. We can also set the a prime equal to 0 here, and then we can solve for x. We got 3x equal to 150, simplify it, and we got x equal to 50. Then we can just substitute the value of x to the y equation, which is y equal to 150 minus 3 per 2x. Put the value of x into the equation, and we got y equal to 75. So the final answer for x is 50, while the y is 75. And the dimension of rectangular plot is 50 by 75 meter. I think that's all for the question number 1, so I'm going to pass it to the next presenter. Thank you.
Question 2. Must airlines require that rectangular baggage carried on an aeroplane be such that the sum of dimension, length, width, and height is 135 cm? Find the dimension of baggage that will maximize the volume given that the length of the baggage must be twice the width. So keywords in this question are: first, sum of dimension, length, width, and height is 135 cm. Other than that, in this question also mentioned that length of the baggage must be twice the width. So that means length equal to 2 times width. So solution here, first we have to illustrate the figure of rectangular baggage. So this is the figure of rectangular baggage that we illustrate. So here, let width be x, y, length equal to x because length twice of width. Steps of solution. Step 1. Since sum of dimension also mentioned from the question, so from here we can conclude it 2x plus y is equal to 135. That means length plus width plus y equal to 135. Step 2. Make y a subject in terms of x. So we got here the sum of dimension. We make y a subject of this equation. Y equal to 135 minus the 3x. Step 3. Find the volume of rectangular. Since in the question also mentioned about volume of rectangular baggage. So here we got length equal to x, width equal to x, height equal to y. Replace y with 135 minus 3x. So this is we have to replace it in the equation of volume. So for formula, volume of rectangular is volume equal to length times width times height. So volume equal to 2x times x times y. So this is the equation, but we have to replace y with this. After we replace this, we got the volume equal to 270 x squared minus 6x cubed. Step 4. We have to do the derivative of volume. From the volume we got from the step 3, we have to do the derivative of it. So dv over dx equal to 540x minus 18x squared. Step 5. Find critical point by replace dv over dx with 0 and solve the x. from the equation, from step 4, we have to find the critical point with the equation. So, we have to replace 0 in the dv over dx to find the x. So, total final for value of x is 30. Step 6. Second derivative to determine the critical point is maximum or minimum. In this step, when we want to find the minimum or maximum point, we have to do second derivative. So from the dv over dx, we have to do second derivative of that. So we got here d square v over dx square equal to 540 minus 36x. So here also mentioned when x equal to 30, that we know in step 5 x equal to 30 is a critical point. So that's why we have to replace in here. So we got negative 540 for maximum point. When we got positive, then it is minimum. But here we got negative, so that's maximum point. From this, we can conclude it. Therefore, when x equal to 30, d square v over dx square equal to negative 540, and it is maximum.
Step 7. Substitute x equal to 30 into y equation to find height, since y is height. Take y equation from step 2, since we know that x equal to 30 is width. So, to find the y, since y is height, we have to replace x with 30. And after that, we get the y value. Then, y value is height value. So, height value for this package is 45 cm. Step 8. Find length when width equal to 30. As we know, that's mentioned in question, that length is twice of width. So, length times width. Length equal to 2 times 30 and get length equal to 60. Therefore, we can see here dimension of package that will maximize the volume are for length is 60 cm, for width is 30 cm. Last but not least, for height is 45 cm.
Now, let's continue to the last question, question 3. A closed box has a volume of 15,000 centimeter cube. The length of the box is 3 times of its width. Find the dimensions of the box that will minimize the surface area of the box. Hence, find the minimum surface area. Before we proceed to the solution of this question, let's find the keyword given from the question. The first keyword is the volume of the box is 15,000 centimeter cube. The second keyword is the length of the box is 3 times of its width. So if we assume the width of the box is x, the length of the box will be 3x. And from the question also, we can observe that the question wants us to find two values. The first one is the dimensions of the box, and the second one is the minimum surface area. Now, let's proceed to the solution of this question. Step 1, we have to find the volume of the box. So, volume V equal to length times width times height. Since the question already gives us the volume of the box, we just have to put the value into our equation. So, 15,000 equal to 3x for the length times x for the width times h for the height. Then we get 15,000 equal to 3x square h. From this equation, we only have to find one value of one variable. It means if we want to find h, we have to put 3x squared to the another side. Then we will get h equal to 15,000 over 3x squared. The second step, we have to find the surface area A and the first derivative of surface area, which is dA over dx. So the formula for surface area is 2 base plus 4 side. two base here refers to the upper base and lower base. And fourth side here refers to the front side of the box, back side of the box, right and left side of the box. So A equal to 2 times 3x squared for the base of the box, plus 2 times 3xh for the front and back side of the box, plus 2 times xh for the right and left side of the box. Then we will get A equal to 6x squared plus 8xh. Continue with the substitution. Since in step 1, we already have the value of h, which is 15,000 over 3x squared, we have to substitute this value into our equation. So A equal to 6x squared plus 8x times the substitution of h, which is 15,000 over 3x squared. Then we get A equal to 6x squared plus 40,000 over x. And another way to express this equation is A equal to 6x squared plus 40,000 x power negative 1. So we already have the surface area equation, which is A. We can find dA over dx. dA over dx equal to 6 times 2, we get 12x. 40,000 times negative 1, we get negative 40,000. And x power negative 1 minus 1, we get x power negative 2. Then dA over dx will be 12x minus 40,000 over x squared. Continue with step 3. We have to find the critical point. The critical point is where dA over dx equal to 0, as stated from Anatasha before. So from step 2, we already have the equation of dA over dx. We just have to equate the equation with 0. So we take this fraction to the another side. Then we will get 12x equal to 40,000 over x squared. And then we have to put this denominator of x squared to another side. Then we get 12x cubed equal to 40,000. Then from here we can find the value of x, which is 14.938. Next, we continue with step 4. We have to determine whether the critical point is at maximum or minimum. So to find it, we have to find the second derivative of our equation. So our equation is of first derivative dA over dx equal to 12x minus 40,000x power negative 2. So the second derivative, d square a over dx square, we will get 12 plus 80,000 over x cubed. And then from here, we can just substitute the value of x, since we already get the value from the previous step. So d square a over dx square equal to 12 plus 80,000 over 14.938 cubed. Then we will get the second derivative is 36. So 36 here means the value is positive, and the positive value means the critical point is at minimum. Now we continue with step 5. Since we already have the value of x from the previous step, we just have to substitute the value of x into the dimensions of the box. So the length is 3x, we just have to substitute the value of x into it, then we will get length equal to 44.814 cm. Next, for the width is x. We just have to put the value of x, then we get the width equal to 14.938 cm. And the height for the box is 15,000 over 3x squared. Substitute the value of x, then we will get height equal to 22.4071 cm. And the last step is step 6, where we need to find the total surface area. And also from previous equation, A equal to 6x squared plus 40,000 over x. So just take the value of x that we already get, and we will get A equal to 4,016.5977 cm squared. Therefore, we can conclude that this is our final answer. The dimensions of the box, which is the length, is 44.814 cm, the width is 14.938 cm, while for the height is 22.4071 cm. And the total surface area is 4016.5977 centimeters square. So that's all for the solution of question 3. Up until here our presentation. We hope that you can understand the whole of our presentation, and thank you.